Hello, everybody. This is lesson 5.3, interpreting and sketching graphs. This is my first time making a lesson for this class, so just bear with me. I'm kind of learning how to use the technology, and I know that it's maybe hard to see me on here just because of the lighting in this room. So hopefully as we go through the semester, I'll be able to figure things out a little bit and it'll get a little bit easier. But anyway, thanks for joining me today. And I know that I already handed out the note package that has these notes in it. So if you have that with you, you might want to use it right now to write on. In the future, I don't know if I'll be able to get paper copies to you. So for future units, you may just have to kind of make your own jot notes and pay attention. But hopefully this will help you be able to do the assignment for 5.3. So this section is on interpreting and sketching graphs. So graphs can be an effective way to communicate mathematical information. Use the graph at right to answer the following questions. So this one is called a scuba diver's dive. We have depth on the y-axis, which is how far below the surface of the water the diver went. And then we have time in minutes along the bottom. So the first question is, how many minutes did the dive last? Well, the dive would start when they went under the water, okay, and it would continue all the way until they came back up to the surface, a depth of 0 again. So the question is, what is this amount of time here? So it looks like so far, for 2 squares, that's 4 minutes. That must mean that each square is worth 2 minutes. So this would be an answer of 30 minutes. For B, at what times did the divers stop the descent? That means at what point did they stop moving downward? So here you can see they're moving deeper and deeper and deeper, and then they stopped. So this person stopped for a minute here, and then they went deeper and deeper, and then stopped the descent again. So I'd say that this happened 2 times. It happened once at 4 minutes and once at 10 minutes. What was the greatest depth the diver reached? So the furthest away they went from the surface was 20 meters. And how long were they at that depth for? Well, they stayed at 20 meters for 2 squares worth of time, which is for 4 minutes. Okay, interpreting graphs. So graphs generally show the independent variable along the bottom. Sorry, just getting used to this pen. And the dependent variable along the left side. There are certain characteristics of a graph that can provide information about a given situation. So for example, if you have a really steep segment, that indicates that a change is happening very quickly or rapidly. Flat segments indicate that no change is happening. And if you look at whether or not your segments have a positive, which means going up as you go to the right, versus a negative, which is going down as you go to the right direction, that can tell us if an increase or decrease is happening. So just looking at this graph here, we've got distance and time. So somebody started 5 meters away from something, moved further away quickly, came back not as fast, stayed at that same distance away for a few minutes, then had a moderate increase, then a steep or quick decrease, then a moderate decrease. So on this graph, every slope is representing a speed. So this is when they were going quite fast. This one's not as steep, so it wasn't quite as fast. Here, they're not moving at all, speed of 0. Here, moving but kind of slowly. Here, moving but very quickly. And here, moving slowly. Okay, let's go to the next page here. So example 1, interpreting a graph. Each point on the graph represents a person. Which person is the oldest? Okay, so here we have heights and ages along the x-axis, and heights were along the y-axis. So which person is the oldest? So if we go to our oldest age, that would be person G. And what was the age of person G? Well, it looks like they're right on that line between the 16 and the 20. So we would say that person G is 18 years old. Just going to go back to my pen here. Which person was the youngest? Well, that would be person A here, and they are 0 years old. Which two people have the same height? So now we'd look at our height level, and we'd see that B and C are on the same level. That means that they're the same height. So we're going to say B and C are the same height, and their height appears to be 100 centimeters. Which two people have the same age? That would be these people lined up along the same age line. So that's D and E. And their age is in between 8 and 12. And so that would be 10 years. Who's taller for the age, person B or C? So B and C are both 100 centimeters, but person B is younger and person C is older. Therefore, person B is actually a little bit taller for their age. Okay, moving on to example 2, describing a possible situation for a graph. So this graph represents a day trip from Athabasca to Kikino in Alberta, a distance of approximately 140 kilometers. Describe the journey for each segment of the trip. Okay, so this part I'm going to type because hopefully it'll be a little bit neater for you guys to read. Okay, so first let's start by describing section OA. So that will be the section going from O to A. So along that section, the person drove a distance of 140 kilometers over 2 hours towards Kikino. Okay, so once again, the segment there that I'm describing, if I just go to my highlighter for a second here, the segment O to A. So OA, they drove 140 kilometers. How do I know that? I'm looking across and seeing the distance. And how long did it take them? I'm looking down and seeing the time. I know that they started in Athabasca, so they must have driven toward Kikino on that segment. Oh, pardon me. Somehow I lost this. Let's get it back up there. There we go. Okay, now let's describe segment AB, the next leg of the journey. So now we're going to be looking at this part here. Oops, sorry. Oh my goodness. AB. Let's get rid of that. There we go. So let's describe segment AB. Back to my text box here. So in segment AB, they didn't go anywhere, which means they stopped for, how long did they stop for? 2 squares worth, which is 1 hour. Okay, now let's describe CB. I think you can follow along on the graph which segment that is without me highlighting it. So now we're going to look at BC. And in this segment, they drove how far? Well, they started at 140 and ended at 90. So this time they drove 50 kilometers back toward Athabasca. They drove for how long? Well, this time it's 1.5 squares. So that would be 45 minutes or 3/4 of an hour. Okay, I will highlight this part just because it was a little bit more confusing. So from B to C, that was this segment. Okay, C to D, they stopped again. Now the question is, how long did they stop for? It appears to be 1.5 squares. Each square, again, is half an hour. So 30 minutes plus half of 30 minutes is, again, 45 minutes. And then our last segment would be DE. So segment DE, they drove the remainder of the trip, which was 90 kilometers, because that's what was left, back toward Athabasca. And it took them 2 squares worth of time to do that. And, oh my gosh, I spelled Athabasca. A little bit funny there. And that took them a period of 1 hour. Okay, so there's how you would describe a trip or a situation looking at the graph and interpreting it. So here we had CD was this part. And then I think I'm almost out of colors here. If I just do a light pink, then that's segment DE. Okay, so when we're describing the situation, we are using both of our axes information. So we're telling how many kilometers they went and how much time they spent at each of those, on each of those legs of the journey. Okay, here is our last example for this section. So example 3, sketching a graph for a given situation. At the beginning of a race, Alicia took 2 seconds to reach a speed of 8 meters per second. She ran at approximately 8 meters per second for 12 seconds. Then she slowed down to a stop in 2 seconds. Sketch a graph of speed as a function of time. Label each section of our graph and explain what it represents. Okay, so we have to decide where we're going to put time and where we're going to put speed on this graph. And so we're going to put time along the bottom and we're going to put speed along the side. I'll try to type so that it's a little bit easier for you to read. Now this is Alicia running. So we're going to title the graph something to do with that. So Alicia's run. I'm going to put time in seconds down at the bottom. Make sure you always have some kind of unit with your label. And then we're going to have speed. And the speed will be in meters per second. That's the speed that they've provided us with. And so I'm going to put that speed along the y-axis here. Now I want to leave a little bit of room because we have to say what everything is worth. So we need to cover at least up to, she took 2 seconds to reach the speed, 12 seconds at that speed, and then 2 more seconds. So we have a total of 16 seconds that we need to represent along the bottom. So in order to do that, I cannot just put 1 second, 2 second, 3 second, 4 second, 5 seconds. I'm going to run out of room. So I'm going to say that every tick mark is 2 seconds. So that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And just because it's a little bit hard for me to write all of those numbers in, I am going to, oops, pardon me. I thought that would just delete that. There we go. I'm just going to mark 10 seconds down here with my pen. Just got to get back up to my pen here. And this would be 20. Now, if it helps you to write 2, 4, 6, 8, 10 on your graph, go ahead. On the left side for speed, the maximum speed that's reached is 8 meters per second. So I think we can actually just count up by 1. So I'm going to make 2 squares worth 2, which is the same thing saying 1 square is worth 1. I'm going to use that scale all the way up the side. That way it fits on my graph. I can even go up to 12, even though we won't have to go that far. Okay, so now let's actually graph the parts of the graph that were described in the story. So at the beginning of the race, it took 2 seconds to reach a speed of 8 meters per second. So 2 seconds matches with 8 meters per second. So I'm going to go to my 2 seconds. Remember, this is 2, 4, 6. So 1 square over is 2 seconds, and all the way up to a speed of 8 meters per second. So if I connect that with our 0, 0 point, that gives me the first part of my graph. Then she ran at approximately that same speed of 8 meters per second for 12 more seconds. So I have to go across for 12 seconds at the same speed. So that's 2 seconds, 4 seconds, 6, 8, 10, and 12. I know that every square is worth 2, so 12 seconds means 6 squares worth. 1, 2, 3, 4, 5, 6. Then at this point, it took 2 seconds for her to slow down to a stop, and a stop means there's no speed left, a speed of 0. So I end on 16. Now we've pretty much finished our graph. So we've got a title, we've got each axis labeled with units, we've got appropriate scales, and now we just have to do this last part here, which is to explain what each segment meant. Oh my goodness, sorry about that. Still getting used to this. So let's explain. And so maybe we should label, just like we had done on the previous graph, with letters, the parts of our graph. So I'm going to call the very beginning O. That's often commonly used at the beginning for the original start spot. I'm going to call this point point A, this point here point B, and this point here point C. That way when we go to explain, we can label our segments quite easily. Okay, so section OA, it took 2 seconds to reach the speed of 8 meters per second. For segment AB, the runner maintained a speed, of 8 meters per second for 12 seconds. And then the last part, segment BC, the runner slowed to a stop in 2 seconds. Okay, so that describes our run here. So we now have a complete graph and a complete explanation. Okay, that takes us to the end of our notes for section 5.3. So at this point, you should be able to do the textbook assignment for 5.3. It's listed on your homework list. If you've lost your homework list, it is available on the Google Classroom as well. Please make sure to hold on to your homework. I will likely ask for it to be submitted at the end of the unit as your evidence of learning for this unit, so please do not lose it. And please do a thorough job of labeling your homework with the sections, the question numbers, and showing your work. I can't give any extra credit for just writing down the answers because they are in the back of the textbook as well. If you don't have your textbook at home with you, that's okay. I've put a link to the textbook on the Google Classroom. So you can check there for a digital copy of the textbook. So even if you don't have anything with you, as long as you can get on the Google Classroom, you should be able to see the homework list and a copy of the textbook, and you can just show your work on any pieces of paper. Okay, thanks for checking out my first video, and hopefully this was a success. And if you have any suggestions for future videos, let me know and I'll try to make them as good as I can. Thank you very much.